Hello everyone and welcome to another exciting machine learning project. Today we are tackling a crucial application in healthcare, predicting diabetes. Diabetes is a chronic disease that affects millions worldwide, and early prediction can significantly help in managing it and improving patient outcomes. Our goal in this video is to build a machine learning model using Python that can predict whether a man has diabetes or not. Throughout this video, we will walk through the entire machine learning pipeline, starting with understanding our dataset, performing essential data pre-processing steps, training a powerful support vector machine model, evaluating its performance, and finally building a simple functional predictive system. So let's dive in. Alright, let's begin by setting up our environments. By loading our datasets, you can download the dataset from Kaggle. I will share the link in my bio, and you can drag and drop after extracting your diabetes.csv to Google Colab file. Here you can easily access and copy its path and load into pandas using panda data frame. So first things first, we will import important libraries. Import NumPy, import pandas, we will also be needing standardization techniques, so we will be importing standard scaler. Now we will need to separate the data into train and test, so we will be importing from model selection the train test split. Now we will be using SVM for this diabetes problem. Now to check the accuracy score, we will be needing the accuracy score from sklearn.metrics. Sorry, there was a little typing mistake. So we will load our dataset for this project is the Pima Indians diabetes data, commonly used for binary classification. So let's load it using pandas. So diabetes dataset is pt.read.csv, and we will copy the path of this file and paste it here. Now let's take a look at the first few rows of our dataset using the head function. As you can see, we have several medical predictor variables like pregnancies, glucose, blood pressure, insulin, BMI, etc. The last column outcome is our target variable, where 0 means non-diabetic and 1 means diabetic. So let's quickly check the number of rows and columns using the shape function. Sorry, I forgot to mention that it is a data set. So we can see that it has 768 rows and 9 columns. Now by describe, we will get a statistical summary of our features showing mean, standard deviation, mean, max and quartiles. So we will be importing using the function describe As you can see, count, mean, standard deviation, minimum, max. It is also crucial to understand the distribution of our target variable. Let's see how many diabetes and non-diabetic cases we have even in our dataset using value counts. So, diabetes dataset, and we are going to check the outcome. Dot value counts. So as we can see, this shows us the balance of our classes, which is important for training a robust model. Now we will deep dive into data pre-processing. Now let's prepare our data for machine learning model. First we need to separate the features, our input variables, from target variables, the outcome. So we will go like X diabetes dataset. Now we are going to drop the only column outcome. And we are going to give it axis 1 because we are going to drop the whole column, and Y will be the outcome column. Now next we will split our data into training and testing data. We have already imported the train test snippet from sklearn.model selection, so we are just going to mention the variables here: xtrain, xtest, ytrain, ytest, and it is from train test split. We will be giving the variables x and y. Test size. Test size 0.2 means that we are using only 20% data for testing and 80% data for training. And I will choose the random state as 2. Finally, we will perform data standardization. Our features like glucose levels and blood pressure have very different ranges. Machine learning algorithms, especially like SVMs, perform much better when all features are on a similar scale. Standardization scales the data to have a mean of 0 and standard deviation of 1. So we will be importing scalar as standard scalar, and we are going to fit the xtrain in this, and then we are going to scale the xtrain scaled, which will be equal to scalar dot transform xtrain. So xtrain will become xtrain scaled. Similarly, we will also scale the test version also. Scalar dot transform xtest. So we have successfully standardized our data. This prevents any information from the test sent from leakage into our training process. With our data cleaned and scaled, we are ready to train our machine learning model. For this classification task, we will be using a support vector machine or SVM. SVM are incredibly powerful and versatile algorithms, especially effective in high dimension spaces. Let's initialize our SVM classifier. We will use the SVC class from sklearn.svm. Specify a linear kernel, which means we are looking for a straight line separation. So our code will be like classifier SVM. From SVM we will be importing SVC, support vector classifier, and we will give the kernel as linear. Kernel. Now we train or fit our model using scaled training data and their corresponding labels Y-train. This is where the SVM learns the patterns and relationship to distinguish between diabetic and non-diabetic cases. So we are going to train the classifier dot fit, and now we'll be using X-train scaled data and Y-train simple data. After training, it is crucial to evaluate our model's performance. We want to know how well it learned from the data, and most importantly, how well it performs on data it has never been seen before. We will use the accuracy score for this. So first, let's assess the accuracy on our training data. This tells us how well the model performed on the data it was trained on. So we will be importing X-train prediction. Now we will import the classifier dot predict and prediction done on X-train scale data. Now training data accuracy is accuracy score of X train scale data, X train prediction, and Y train data. We are going to print accuracy and training data accuracy. It will be printing our training data accuracy. So our training data accuracy is near about 77%. Next, more importantly, we calculate the accuracy in our test data. This gives us a realistic measure on how our model will perform in a real world scenario, as the test data is completely new to the model. So we will create a new variable X test prediction, and we will give as classifier dot predict, and in this we will pass the X test scale data, because we are getting known about the test data accuracy, which is accuracy score of X test scale data, prediction data, and Y test data. We are going to print accuracy score and the test data accuracy. So the testing data accuracy is 76%. As we can see, our model achieved a good accuracy score of around 76 to 77% of accuracy score. This indicates that our model is performing well and generalizing effectively to unseen data, which is okay for a prediction task like diabetes. Now for exciting part, turning our trained model into a functional predictive system. This is where we can take new patient data, feed it on our model, and get a prediction, diabetic or non-diabetic. So let's, for example, we will take first example of the data for testing our model. So let's see if it can predict about our data or not. So we will give the input data. Now we need to convert this input data into a NumPy array, as our model expects array-like input only. So input data as NumPy, which will be equal to np.asArray. AsArray is a function which converts the normal data into NumPy data, Panda data frame to NumPy data array. Since our model was trained on multiple samples, but we are predicting for a single instance, we need to reshape the array. This tells the model we are providing one sample with multiple features, not multiple samples. So we need to reshape the data. Input data reshaped and input data as np dot reshape. This is a cool feature of Google Colab. It automatically predicts what you are going to type and helps you in your coding experience. So as we have reshaped our data, we must standardize this new input data using the same scaler that we fitted our training data. This ensures consistency and proper scaling for the model's prediction. So we will import a new function as standard data, and it will be carrying scalar.transform. Now we are going to print the standard data. As you can see, we have got the scaled values from input data. These are the similar values, but these are scaled values. Finally, we will pass this standardized input to our trained classifier to get a prediction. So we will be creating a function called as prediction, which will import classifier.predict, and in which we will put the standardized data. And now we are going to print the prediction. The prediction variable will contain 0 for non-diabetic and 1 for diabetic. We can use them as if-else statement to print a user-friendly message. So if prediction is equal to 0, then print this person is not diabetic. Else, sorry, I forgot to type here this. Else print this person is diabetic. We have put the twice. Now we will run our model. So as our example, it has told us that the person is diabetic. We can also test with another example. For example, here in this data, the person is non-diabetic, and I will copy and paste these values in our model. I will remove the last comma. It has successfully standardized those values. Now, as we can see, this also told us that this person is non-diabetic. This demonstrates how you can integrate your machine learning model into a practical application to assist. And that concludes our project on diabetes prediction using machine learning. We have covered the entire process from understanding the Indian diabetic dataset, cleaning and preparing our data, and splitting and standardization, training a robust support vector machine classifier, evaluating its performance, and finally creating a functional predictive system. If you found this video informative and helpful, please give it a big thumbs up. Subscribe to the channel for more machine learning projects and tutorials, and feel free to leave any questions or comments down below. Thank you for watching. I will see you in next video.